All right, welcome back to Easy Math with Nick. Today is video number 10, double digits. Woohoo! Um, and today we're going to be tackling some AP statistics questions, mainly from last year's 2024 exam. And these questions will loosely be based on binomial geometric distribution. So we'll see what these questions have in store for us. I haven't done them before, but I took a look at them to make sure they were good for the video, and I think they are. So, all right, let's begin. Just as a note, for the AP Statistics exam, you are given an equation sheet, so you might see me reference that a couple times today. If there's an equation I just can't be bothered to remember. So, yeah, let's begin. All right, in an online game, players move through a virtual world collecting geodes, a type of hollow rock. When broken open, these geodes contain crystals of different colors that are useful in the game. What is this, Roblox? A red crystal is the most useful crystal in the game. Okay. The color of the crystal in each geode is independent. Okay, this is the most important part here. Could just skip the rest of it. And the probability that a geode contains a red crystal, 8%, 0.08. Sarah, a player, will collect and open geodes until a red crystal is found. Calculate the mean and distribution of the number of geodes. This is just big words for was the expected number of, geodes Sarah will need to open to find a red crystal. So, if until a red crystal is found, when we have a situation where we're conducting trials until a success happens, that is a big point, a big hint. I wouldn't say hint, a big sign. I'm thinking of a different word, but a big indication. There you go. That we're dealing with the geometric distribution. And so the geometric distribution, if you write it out as an equation, the probability that we have, let's say, a successes. No, okay, it takes a trials to get the first success. I should say, not a successes. That's a different. Means something completely different. In n trials is uh, probability of 1 minus p. So 1 minus probability of success for n minus 1 trials times p. So the probability of success. What this means is that on this last trial, we succeed. So the probability of succeeding on that last trial, as we're dealing with independent events here. This is our last trial, and for the rest of the trials, we fail. So we fail for n minus 1 trials. And we finally succeed on the last. So last trial. So that's what I mean here. I could put a 1 here just for clarity to make it more clear. But I think I was pretty. I think what I did there made sense. Okay, so that's just the formal equation for a geometric distribution. If you want to see, for example, like the probability uh, of it taking a specific number of trials, a number of trials to get a success. So that's not really relevant for what the question is asking, though. They asked for the mean. So say, just logically speaking here, I know it's on the equation sheet, but just logically speaking, let's say our probability for a red crystal was not 0.08, it was 0.5. So what 50% chance of getting a red geode, a red crystal, whatever. How many trials would we expect it to take to get a red crystal? Well, 2 trials, right? Because it's a 50% chance. Go figure, if we do 2 trials, we should have probably got a red crystal, because that just logically makes sense, right? We did 2 trials, it's a 50% chance. So that makes sense, right? Let's say the chance was 0.25. Was 25%. The probability was 0.25, 25%. How many trials would we expect? 4, right? That's how, I mean, going by this logic, that we would expect it to take 4 geode openings to get that red crystal. If we had p equals, this is very informal what I'm doing here, but it's just to 0.25. Oops. And just for final example, what if our p was 0.08? What we have in the question, right? Well, that's a lot harder to mentally think of, right? But here, our expected was 1 over p, 1 over 0.5. So that's our, if we look at our equation sheet, I'm just trying to logically, for a geometric distribution with parameter p, this is our, this here is our expected, this is our mean, which is what they're asking for in this question. So it's 1 over p. So what's 1 over 0.08? 1 over 0.5 was 2. 1 over 0.25 was 4, just to show the trend there. So 1 divided by 0.08, do this on my calculator, 12.5. So the answer to this is 12.5 geodes. All right, that took way too long to get an easy question done, but I just wanted to go as in-depth as I could. Now, standard deviation, that's a little bit more tricky, right? Thankfully, you don't have to memorize it. It's on the equation sheet. Radical 1 minus p over p. So, because we know it's geometrically distributed. I don't know if you have to state that, but I mean, they don't ask to explain. They do ask to show your work. I think we used the letter A, right? Standard deviation of A. I think that's what we used. Whatever. I mean, we're just calling that variable A. This is going to be 0.92. Radical 0.92 over 0.08. Whatever that is. All right, 11.99. So I'm not going to go over what that means in the context of the question, but that's part 2 for number A, for part A. All right, another player, Conrad, a guy named Conrad, decides to play the game and will stop opening geodes after finding a red crystal or when 4 geodes have been opened, whichever comes first. Okay, now we're spicing this up. I like this question because it doesn't, to my knowledge, align to any, like, it's not binomial or geometrically distributed. It's sort of like its own thing. So, and supplementing a 4 geode, whichever comes first. So, okay. Or when 4 geodes have been opened. So the probability of not finding a red. Okay, so let's do the let me not get ahead of myself. Calculate p of y equals probability that number of geodes equals 3. This means that Conrad has not found the red crystal yet, because if he he found the red crystal on trial 3, which means that we are dealing with the geometric distribution here. So probability that y equals 3 equals 1 minus 0.08 to the power of 2, because he had 2 failures, but then he had 1 success. If you want to make sure this is even what you're doing is right, they give you probability of y equals 2. They give you that, which is nice. So just going by, let me just see if they did their math correctly, right? I'm assuming they did. And they did. That's correct. To the exact decimal too. So we know we're doing it the right way then. So, and this is going to be 0.0677. So there you go. Now, P of y equals 4. This is interesting because we're not really dealing with the geometric distribution anymore. We're not, it's not, now we're, this is not a trial on which we get a red geode. Not necessarily, right? It's just after 4 geodes have been opened. So, by the time we get to this point, it's just, you just kind of think about it logically. On trial 4, it's going to end anyway, right? We're going to be done on trial 4. There is no trial 5, right? Y can't equal 5 because we stop at 4. So really, P of Y equals 4. Just very simply equals 1 minus P of Y equals 1 minus P of Y equals 2 minus P of Y equals 3. I can squeeze that in there. There you go. That's it. Because we're not going to be going beyond 4, right? Because we stop at trial 4. You might be tempted to use the geometric distribution here, but we don't necessarily get a red geode on trial 4. That's the whole point of the question, right? So, is this a little bit tedious? Maybe. But I don't think it's all that bad, right? So, if we work that out, give me a moment here. It's never a good idea to do mental math. With this, I don't even think you could. If you do all better, good for you. All right. I got a somewhat nice number. 0.7787. So there's a 78% chance basically that we're going to have to go to 4 trials. That we're not going to get that red geode. We're going to have to go to 4 trials to get a red geode, or maybe not even at all, right? It's not guaranteed that we're going to get that red geode on trial 4. So there you go. Consider the table on your results. Calculate the mean of the distribution of the number of geodes. Okay, this is going to be a little bit tedious, which is why I think I purposely brought it down here so I can have some more space for this. The mean, it's not going, because we're not just dealing with the geometric distribution, a common mistake here is just going to be 1 over P. Because, yeah, we were geometrically distributed up until trial 4, right? Trial 4 is where we just stop anyway, right? So it's not going to be, how do I, it's not, you can't do that. So just to find the mean, we're going to find the expected value of Y. Let me, where's the eraser? Wow, it took me that long to find the eraser. So equals when 1 times 0.08. I'll write first and then explain what I'm doing here to the best of my ability. Let's see. This is just what stood out to me as the most straightforward way to go about this. So this is how we're going to find the mean. So the mean is for the distribution of the number of geodes, column or open. We're finding the expected value of Y, because we don't really this doesn't align just to like the geometric distribution, right? It sort of deviates from that, if, as I've stated probably 3 times by now, right? So you can't just do 1 over P, because then because it doesn't, that wouldn't get you the right answer. I don't know how other way to put it. But by doing it like this, you'll be able to find the mean of the distribution. So I'll put this in my calculator. I don't really know how to elaborate on this other than just doing it. My apologies. This is basically the best way I can explain it, akin to other questions where they give you a probability of taking a number of trials to get to get a success, and that's then you just multiply each probability by what you essentially do. It's okay. Let me just do the work first. I think you get the point. I sort of deep down want to explain a little bit more, but I think mean is 3.53. 3.5371. So what this means in context of the question, that at least I can explain, is that On average, Conrad will open 3.5, 3.5 geodes when he's doing this game. So, all right. Interpret the mean. Oh, there you go. That's what I just did. I didn't even think about part two. Well, what I was just saying is uh, Conrad will open 3.5 geodes on average. Oh, the best way to explain this is he's expected to open 3.5 geodes when playing the game. So obviously this doesn't you can't open half of a geode, right? But what this really, so it's not really like he couldn't open 3.5 geodes, but what that really means is that when he's playing the game, if he plays the game like multiple times, and on average, if you took the average of the number of geodes he did on his multiple times of playing the game, it's going to average to 3.5. So that's, or 3.5371 if you want to be pedantic. But that's the interpretation of the mean here. So it's so close. It's close to 4 because we looked at probability that of going to four geode openings is quite large. It's like what 77, 78%. So in the pretty much majority of trials, times he's playing this game, he's going to go to 4 geodes. So that's why this number here is close to 4, because majority of times he's going to 4 geodes, and there's only less than 30% chance that he gets that red geode before reaching that 4th trial. Okay, I felt that was a good question. This time we're doing one from 2025 exam. I felt like that last free response question was a good one. If I was taking this exam, I'd like this question because what they give you enough on the equation sheet so that you don't really need to memorize like the standard deviation for standard deviation of a geometrically distributed variable, right? That they give you that, so that's nice. But I digress. Let's continue. All right, time for me to read this to you. Mrs. Fay is a manager at a restaurant. To improve the dining experience for her customers, she uses a digital music service to create a playlist of songs that will be played in the restaurant. The playlist contains 1,000 songs. Wow, okay. And consists of 4 different types of music in the following quantities: 200 country songs. This is important. I feel like this will be very important. 400 pop songs, 100 rock songs, and 300 jazz songs. The digital music service will select songs at random from the playlist to be played in the restaurant. Any song could be replayed at any time. Okay. So I think this last line essentially means that with replacement, usually we just make that assumption anyway, but I think that's what that last line is there for, unless it's just there to confuse you, which they do a lot. Okay, part part I, whatever. Don't even know how to say that. Suppose one song is selected at random to be played. What is the probability that the song is a rock song? Okay, I don't think it gets easier than this, right? Even if you've never taken a statistics course in your life, you probably can still do this. There's 100 rock songs, and the total number of songs is 1,000, so it's going to be 0.1, so 10%. I don't know why I use squiggly equal sign, but there you go. It's not that deep. Suppose 2 rock songs are selected at random to be played. What is the probability that both songs are rock songs? Okay, because any song could be replayed at any time. That means we are with replacement here. So, okay, I guess that adds a little bit of depth. But this is just going to be the first song. We have 100 to choose from. In the second song, we also have 100 to choose from. So it's just going to be 0.1 times 0.1, which is 0.01. You might for me clicking on my calculator there just to make sure I'm not losing it. But there you go. That wasn't so bad, right? I don't know on the stats exam. Let me know for the AP stats guys in the comments if they want you to express probabilities as decimals or percents. I know in my experience, most people don't care either way, but I don't know how College Board. I don't know if they're hellish about that. Hellish. I don't like that word. Hellish. Yeah, yucky word, but you know what I mean. Part B. Every 1 hour period, I doubt that's important. 20 songs will be played at random, and any song could be replayed at any time. Okay. Mrs. Faye is interested in how many rock songs will be played in a typical 1 hour period. Define the random variable of interest. Okay, so we only care about how many rock songs. So it's either, the song could either go into two categories, right? Song. It could either be rock or paper. No, okay. Rock, paper, scissors. No, okay, I was gonna make a joke, but forget it. Rock or not rock? Non-rock, I'll say. So, the song could either be rock or non-rock. So there's two outcomes here, um, and we know the probability of it being rock, right? Probability 0.1, right? We found that out from the first question, right? And we know n is equal to 20, number of songs we're playing here. So we have all the information to confidently say um, that this random variable for the rock songs is binomial has a binomial distribution. Binomially distributed is what I want to say, but that's a mouthful. Um, because we're doing what n Bernoulli trials to get technical. Because there's two outcomes here. It's either rock or not rock. We don't care if it's specifically pop, country, jazz. That doesn't matter to us here. We only care about if it's rock or if it's not. So that's why there's only two outcomes here, and that's why it's binomially distributed. So the random variable of interest to Mrs. Fay, define the random variable. The random variable is the number of rock songs chosen. So random variable. Can draw a line here. This was what we did for part A. This is what we did for part B. Just so when you're looking at this, it's not just a mishmash of work. Random variable is number of rock songs played and is binomially distributed. The reason it's not geometrically distributed is we're not playing songs until we get a rock song. That's not what she's doing here. She just wants how many rock songs will be played in a typical 1 hour period. So she's interested in, say, like the probability that 3 rock songs are played. You know, that's not. She doesn't care about how many songs it takes to get a rock song. If that is what we were doing, then it would be geometrically distributed. But that's not what we're doing. So. The AP statistics exam, which surprised me a little bit, only expects you to know the binomial and geometric distributions and recognize what those are. It doesn't have negative binomial or hypergeometric, which sort of surprised me a little bit, but whatever. I think that'll be my next video topic. Give me a second. There's a fly right there. I get it. Give me a minute. All right, I'm back. Hopefully the fly doesn't bother me. What was a minute for you is, what was a minute for me was half a second for you. So thank goodness for the pause feature. Okay, we're back. What were we doing? We're doing B part I. And it's binomially distributed. That's what I was going to write. Okay, was the expected value for the random variable in part B I. Okay. Well, logically, we're now doing. We're playing 20 songs, right? And the probability of getting a rock song is 0.1. So just logically, without even looking at the equation sheet, expected value. We're gonna call it R for rock. I cannot draw an E for the life of me. Holy. Expected value of R. Let's do a squiggly. Is just going to be the number of trials we're doing times the probability of getting a rock song. So with 20 songs times chance of getting a rock song is 10%. So it's going to be 2. There you go. I don't think you're supposed to circle on the AP exam. I know that was something for calculus, but don't know that. All right. That was pretty easy, right? So when we play 20 songs, we're expected to get 2. So there you go. Okay, part C now. We're almost done with the video today. Don't worry. Recall that in every 1 hour period, 20 songs will be played at random. And any song can be replayed at any time. How many times are they going to say that? Determine the probability that 4 or more rock songs in particular 1 hour period will be played. So we want the probability that X is greater than or equal to. R is at greater than or equal to. That's what I meant to say. Oops. Equal to 4 equals what? That's what we're looking for here. Well, there might be a better way to go about this, but I'm thinking about what the complement of this event is. The complement of R is greater than or equal to 4 is that R is less than 4, right? So probability that R is greater than or equal to 4 is going to equal 1 minus the probability R is less than 4. And so what is the probability of R is less than 4? Well, that we can feasibly solve, right? That's going to be 1 minus the probability. I'm going to do brackets here. Probability that R is equal to 3 plus probability R is equal to 2 plus the probability R is equal to 1. And, well, I guess also probability that R is equal to 0. Almost forgot that. You don't want to forget that. So this is sort of a tedious question. Oops, let me try to get the brackets in there. Because now we have to, I'm going to bring my work here now. Now we have to solve for all those probabilities, right? So probability that R is equal to 3. Let's do that here. Probability that we get 3 rock songs is that, what is our binomial distribution here? Let me write the equation for that. For binomial distribution, probability equals P P to the X, because we have X successes, 1 minus P failures. And we have N choose X because that is, we can arrange our successes in that many ways. So, okay, I'm not going to explain why that's the case, but you can logically deduce that yourselves. Okay, so probability that R is equal to 3. So we're 20 choose 3. P to the power of, 0.1 to the power of 3, 0.9. This was supposed to be 1 minus X. Oops. Wait, oops, N minus X. What am I doing? N minus X. So we're going to have, what, 20 minus 3, so 17. Okay, so if we, that's something. If we put that in our calculator, Math, NCR. 20, choose 3. Okay, that's a small, not that large of a number. Okay, so by typing all this in my calculator, by the way, this is not, as I mentioned in the previous video, this is not 20 divided by 3. That's 20 choose 3. So don't get confused there. That's an easy mistake to make. 0.19. Okay, now we just have to do something equally as annoying again. So R equals 2. Now at least we know the format. 20 choose 2. 0.1 squared. 0.9 to the power of 18 equals, okay. This is why they give you so much time on the AP Stats exam, right? Because stuff like this takes a while. 9 to the power of 16. All right, this is a significantly bigger number, 0.352. I'll go to 4 decimals, 2 and 1, just so I can get a precise answer. For probability that we get one rock song, we could arrange that one rock song 20 choose 1 ways. It's going to be 0.1. Oh, why did I put an equal sign there? Let me just put an X there. All right. Hopefully it makes sense, the equation for the binomial distribution, because we have this coefficient out front, this binomial coefficient, which is where it gets its name, funny enough, because we can order that, let's say, one success, 20 choose 1 ways. So that one success could be on the 19th song or the second song. I mean, it could be anywhere there, so we have to account for that. It's not like the geometric distribution where our success is on that last trial. That's why up here, we didn't have, where we got to scroll up way up here. There was no binomial coefficient here because we didn't need it. Because we knew that success is on the last trial. And we don't, and all the failures come before it. That's why there's no binomial coefficient here. But here, you need that. And this here is self-explanatory. This is your probability of getting success and probability of getting that many failures, 19 failures. So multiply by that. Okay, that's self-explanatory at least. But that's why you need the binomial coefficient front, which I think is more difficult to understand. Okay, let me plug this. I'll plug all this junk in my calculator. 20 choose 1 is just 20. I don't know why I bothered to write that, but I don't know. All right, now we're getting to smaller numbers. And finally, probability of getting no rock songs at all, which is, all right, this should sort of make sense why this is the largest number here, because look here, our expected value was 2, right? So we expect to get 2 rock songs, which is why the probability of getting 2 rock songs is the greatest. And as we sort of deviate away from that, the probabilities get smaller as we get further away from 2, because we expect to get 2 rock songs. That makes sense. I think I just said the same thing twice. But now the probability of getting 0 rock songs is going to be smaller than anything we've seen before, I predict. So 20 choose 0. Do I even have to write that? That's just 1, but I'll write it. 20 choose 0 times 0.9 to the power of 20. I'll be formal. Damn it. Excuse my language. So this should take absolutely no time to type in my calculator, but 0.9 to the power of 20 is, as I said, as we expected it to be. It's smaller than anything. It's a smaller probability than anything we've seen before. So there you go. All right, now we just add all these up. It's going to take a minute, but this I could probably just do on the page, but for sake of time, this video is surprisingly over half an hour. Wow. Time flies when you're having fun, right? Don't answer that question. Um, I put all those in right. 1901. Okay. And okay, we get now we can go where my arrow is leading us. 1 minus 0.934. So the probability of getting more than probability of getting as many 4 more rock songs is going to be that's the wrong symbol. That sort of looks like the wrong symbol. Oops. 1 minus 0.934, which equals, I could do this in my head, but getting tired, 0.066. So that's pretty small, right? Getting more than 4 rock songs would be quite an anomaly, which segues into our last question for today, part C, II. Suppose 4 rock songs are played. If we get 4 rock songs, does this provide strong evidence that the song selection process was not truly random? I would say yes, it does. And I'm just going to give a verbal explanation because without even doing a hypothesis test that, or no hypothesis is that it was whatever. Without even doing any of that, I'm not even going to think about our null hypothesis would be that the probability of getting a rock song was 10%, and our alternative that it was greater than 10%, right? Or not equal to 10%. It doesn't even matter because that's not what they're asking. They say don't do that. But I would say it provides strong evidence because our mean here, we expect 2 rock songs to be played, right? For 4 to be played, that's significantly that's a significant deviation from our mean. So I would say that, yeah, I wouldn't I would say that we're far away enough from the mean for it to have good evidence to suggest that the song selection process was not random. Because as we saw here, the probability of getting 4 more rock songs within our 20 songs that we choose here is 6.6%. That's pretty small, right? So I would say that to get 4 rock songs, that's just far enough for me to say that it was not truly random. It's a pretty small percent, and just to get 4 songs, yeah, I think that's I think it's fair to say that the song selection process, we should start thinking about whether it's random or not, and we have pretty good evidence to say it's not if we get 4 rock songs within the 20. Just going based off of logic, without even doing like a test or anything. There you go. Mentally, I was. I'm not gonna talk anymore about that question, but I would say yes. There might be another way to justify it. That the AP Stats curriculum, AP Statistics, I should say, curriculum prefers, but I think that's the best way to go about that. For Part C, for the first thing, for the Part I, Part C for Part I, Part I for Part C. I don't even know how to say that. Let me know how you say that. I think the way I did does take quite a while, but I think that's the best way to go about it. If there's another way, let me know. But that's the best way to go about it. Because the probability that 4 more rock songs is going to be 1 minus the probability of less than 4 rock songs, which means I'm either having 3 rock songs, 2 rock songs, 1 rock song, or no rock songs. So those are the 4 scenarios that we take into consideration when we start thinking about the probability of getting less than 4 rock songs. So because we're dealing with discrete variable here. Okay, I think that's all I wanted to cover today. We're bordering on 40 minutes here, so I'm wrapping it up. This is video number 10, and we went over questions today that involve both the binomial and geometric distribution. So the title lived up to its name. So that was great. Thank you for watching. You made it this far. If you made it this far, thank you for watching. Even if you didn't, thank you for watching. I know you're not listening to this if you clicked off the video already. All right, I'm getting way too pedantic here. There you go. Thank you for watching. Whew. Enough yapping, right? Enough yapping. That's my quote. Enough yapping. All right. Thank you.